another video on Apache Beam code transformation part 3. So in this video we will see what are the different transformation available to perform regular expression related stuff, right? And also we'll see a concept called with the timestamp. So I'll try to explain in detail when we are doing the demo. Okay, so the first thing is regular expression. So whenever you have a requirement like to parse text data or strings based on some pattern, right? So regular expression comes are very much useful in such cases, right? So even Apache Beam is providing some inbuilt regular expression related transformations. We'll try to use them, right? So to parse our text data or strings. The second is with timestamp. Whenever you're trying to work streaming data, right? Because Apache Beam supports both to create batch and stream pipelines, right? Whenever you are working with stream data, so stream data means continuously coming data. In such cases, we'll have to, in order to apply Apache Beam grouping or combine transformations or other transformation on top of stream data, so we'll have to logically divide the data based on some time. We call it as a window in Apache Beam, right? So in order to divide that into windows based on the time, we'll have to have a timestamp associated with each of the element coming in the pay collection. So with this particular transformation with timestamp comes very handy in such cases. Whenever you have to assign some timestamp to each of the element available in the pay collection, you will use this particular transformation, right? So in the demo, we'll see all these regular expression related transformation like match, find and split replace with example and also with timestamps. Like, so there are three cases we are trying to demo here. For example, if the elements from the P collection is having some event time already available in the Unix time format, we'll have to convert that into a standard time stamp format, right? So by using our transformation with timestamp. Or else if that particular data is having some event IDs in the chronological order, then we'll have to convert them into seconds by using our transformation. Or else if the data doesn't have any timestamp at all, in such cases you will assign system timestamp, right, or processing timestamp. So we'll see them in detail, right? Let us go to the demo quickly. Okay, so now I'm into my Google Cloud platform. So I've been using the same Apache Beam Python notebook. Okay, so I've already written few examples, right? So I'll try to explain them one by one. Okay, first thing is regular expression, as I already told. So here I have this P collection, simple P collection. It has multiple lines in it, right? So it has some pattern, right? So what I'm trying to do, I would like to extract a characters, two characters, right? Or else digits from this text or line of or strings or collection of strings, right? So this is what the match pattern I've been using. So that first character can be between A and D, the second character also between A and D, and also it can be a digit, right? Then I'll try to filter those values and try to output that. Okay, so here I'm using in this particular example I've been using this map and print function. I'm not using interactive beam show method, because whenever you use interactive beam show method, but if you have output like string list or tuple or key value pair, we can't differentiate between them. They would be printed similar. We can't differentiate between a list or tuple. So that's why I'm using map print functionality, which would clearly differentiate between list and tuple. Okay, so now let us try to use this beam regex match. So what it will do, it will try to match the pattern beginning of each line. Okay, so as per this given pattern, regular X given pattern. So let me try to print that first P collection. You can see, so AA, BB, CC, DDD. So we do have digits at the end of the string, because match works like it always try to match the beginning of each string. That's why it is returning. Okay, only AA and BB and CC and DD. Second case, all matches. The difference between matches and all matches, like, so all matches will return the matching pattern along with the groups in the iterable format. So it will return the values in the list format. Okay, let me try to print that. Now you can see it has been returning values in the list format. This is the matching pattern and the group. Okay, so next, if you have to print the values in the key value format, you can use this regex match kv, right? So it will just try to print the match pattern along with the groups in the key value format. Okay, so let me try to print. You can see it is in the key value format, right? So if you try to use this interactive beam show, you can see the difference whether it can be a tuple or list. Okay, that's why I'm using this map print functionality. Okay, next we'll see find. So find also same thing. It tries to match the pattern which is given here in the entire string, but it will try to return only first occurrence. Okay, in case of match, it will only try to match the beginning, but find will try to match in the entire string, but it will only return the first occurrence. Right, now see, we'll try to see this output, how it look like. You can see AA, BB and also 35, because 35 is available in the between of the string, right, and in the middle of the string, I mean, right. So that's why it is returning 35, right, but only first occurrence. Okay, and next thing, find all. Find all will try to search the entire string and it will try to return all the matched patterns. Now it should return this AA, BB and also this digit. Okay, let us print that and see the output. Now you can see. So and always it will return that output in the iterable or list format. Okay, this is find all. So all these are, I mean, core concepts in Python or regular expressions, right? I don't have to explain much over here. You can just go and check Python, or we have this regular expression feature in many of the programming languages. Okay, now if you have to return that in key value pair, so just use this find kv. So then it will return the match in a key value format. So it will return AA even 10 key value, BB 9 key value, something like that. So this is how you can use match and find all. Okay, now we will have this transformation replace. If you have to replace something in a string, right, with some pattern, then you can use, right. We do have replace all, which will replace entire string with the given pattern. So I'm trying to replace this space with a comma, then you can use this regex replace all. So this is the data, input data. Now our output data should be separated with the comma now. Okay, I just wrongly commented it out. Now it should give that output. Now you can see this data has been separated with comma. Okay, so now if you have to replace only specific part of the string, right, then you can use replace first. If you use this replace first, it will only replace the first occurrence of the space with the comma and then rest remains the same. Now you can use this replace first. Now it has replaced this first occurrence of the space with the comma and then rest remains same with spaces. The last one, splitting the string. So you can use this split regular expression. So wherever you find space, you can split that entire string into multiple parts. Now this will return a list as output. You can see the list iterable. Okay, this is how you can use regular expression related transformation you can apply on top of text data, right. I hope you understand this concept. Now let us go to the with timestamp transformation. So we'll see 3 examples over here. The first example is this. For example, let's say in the data, in the stream data, if we have a timestamp related information in the form of Unix time, so we'll have to convert that data into our standard date timestamp, right. For that we will use this transformation along with Purdue, right. So what this Purdue will do, right, so it will take data coming from this timestamp value transformation and it will try to perform the transformation which has been written over here, and it try to emit that output in the desired output format. Okay, so in this example, so this data has this fruit name and the timestamp in Unix time format. So what we'll do, we'll try to pass the data and also that timestamp related information to this transformation. This transformation will output that data and that will be given as input to the Purdue over here. This Purdue will take that plant information, that means the data, and also timestamp related information, that is Unix time. Then it will convert that data into our standard date time in UTC format, right? So now we'll print that data, how it look like. You can see now this is this particular timestamp is available in our standard date time timestamp format. Okay, so this is how you can use this transformation and Purdue in combination to assign timestamp to each of the element, okay, available in the P collection. Okay, this is one way. The second way, if we have the data, right, so we have the data over here and we have event IDs. Okay, instead of some Unix time, we have event IDs in chronological order. You can see these numbers are in sequence. If we have the data like this, we'll have to convert this event IDs into seconds. For that, again what we'll do, we'll use this window timestamp value transformation. We'll pass the data and also event ID as one of the input argument. Then this will be given as an input to our Purdue. So what our Purdue is doing, our Purdue is doing it's taking plant or data as an input and also timestamp, which is a event ID. So it will take that event ID. So what it will do, it will take that event ID and it will try to multiply that event ID with microseconds. So that is what I've been doing, right? So here, and then we'll divide that whole value by again microsecond, then it will be converted into seconds. That is what we are trying to do. Then we'll try to emit this event ID in seconds and also the plant name, right? Let's try to print these values. Okay, now it will look like this. This is a P collection. This is how, see, this event ID 1 has been multiplied with the microsecond. Again it will be divided with 1 microsecond, so that it will be converted into seconds. So now you can see 1 second strawberry, 4 seconds carrot, 2 seconds, something like that. So it will be done like that. In the third case, if we don't have this P collection doesn't have any time related data, then we'll have to assign system timestamp to it. So that is what we have been doing here. You can see to this transformation we are passing again the data, and since it doesn't have any time related data available, we are just trying to assign our system timestamp. Then it will output the element value associated with our system timestamp, right? You can see this here. So this is how we can assign timestamp to each of the element available in the P collection. This is very much helpful whenever you are working with stream data, right, to divide that stream data into windows. So we'll discuss more about this windows concept. So whenever we are trying to do a video on windows concept when you are trying to work with stream data. Okay, thank you all for watching this video.